All right, so I think I'm recording. Here they give us a function f of x, and they ask us to find the inverse and to determine if that inverse is a function or not. And you may or may not be able to kind of visualize what the graph of a square root function looks like. So I won't use that in determining whether or not this function is one-to-one and whether or not I have an inverse. I'm just going to jump in and do the technique. I'm going to switch the domain and range. So I've got y is equal to 6 minus the square root of 3x minus 7, and I'm going to switch the domain and range, the x and y. So 6 minus the square root of 3y minus 7. And now I need to solve this equation for y. So I have the square root of 3y minus 7 is equal to 6 minus x. And I am going to square each side of this equation. So when I square the left-hand side, to balance the equation, I have to square the right-hand side. So I have 3y minus 7 is equal to the 6 minus x quantity squared. Let's add 7 to each side. And I'm going to do a little trick here. 6 minus x and x minus 6 are equal and opposite. So one of these is going to be positive and one is going to be negative. But since I'm squaring them, I can rewrite 6 minus x as x minus 6 because I'm squaring it, and I haven't changed the solution set of this equation. But I have visually changed it so that it will be easy for me to look and see what the vertex is by getting this in vertex form. Let's give myself a little bit of room here. All right. Let's divide everything. Let's multiply everything by 1/3. So on the left-hand side, I have 1/3 times 3y. And on the right-hand side, I have 1/3 times x minus 6 squared. And to multiply 1 by 1/3 is the same as to divide by 3, so I can write that like this. These inverses have a product of 1. All right. There is something that I have neglected in solving this, and that's to, when we switch the domain and range, and we switch just the variables x and y, we probably need to look at the actual domain set and range set and think about how that affects the graph of this equation. So I'm going to return up here to the original function f, and I need to find the domain of f. So this 3x minus 7, I need that to be 0 or positive. So I'm going to add 7 to each side and then divide by 3. So I know then that the domain of this function f is 7/3 or larger. Now, to determine the range of this, we're going to have to go and use the graphing calculator. I believe what we'll have is from negative infinity all the way up to positive 6. but I don't think that you have the skills yet until we look at a later skill packet to actually visualize that. So let's see, do I have, nope, I thought I already had this keyed in. Sorry about that. All right, so let me key this in real quick. This Desmos graphing calculator understands function notation, so I can key it in as f of x and 6 minus, and if I type SQRT, it understands that abbreviation is for square root, so it's really kind of a neat thing, and it's free. All right, so if you look at the graph here, you can see that exactly what I had said is happening, that this point right here is the maximum point of this graph. Well, I thought it would give me, there. How come I must not be hitting it. All right, so let's make a table. So when this -6 right here, let's see, at 7/3. So no, 7/3 is giving me, yeah, 7/3 is giving me 0. Right, which has a y coordinate of 6, and there is the point right there. So it's exactly as I suspected, that the range is from -infinity all the way to +6. So that's a difficult thing to determine until you build a little bit more knowledge of the library of functions, and you're able to sketch out the graph of the square root of x, and do these transformations and shift that graph left or right or up or down or stretch it or shrink it. And we do look at that later on. But anyway, I used the graph to get this range. Well, why am I doing this? When we switched x and y, this now becomes the domain for this inverse becomes -infinity to 6. And the range of this inverse becomes 7/3 to +infinity. So when I come down here, normally when we look at this quadratic function, we just say, hey, there's no variables in the denominator, there's no square roots, so the domain is all real numbers. But in this case, we can't do that, because when we switch the domain and range here, we are now forcing the domain of this function to be from -infinity. Oops, that was stupid. There can't ever be a bracket at -infinity. So from -infinity to 6. So since this is in vertex form, what does this graph look like? Well, it opens upward, and the coordinates of the vertex the coordinates of my vertex here are 6, 7/3. And with the domain being from -infinity to 6, that's the left-hand side of this parabola. See, for values of x that are bigger than 6, the right half of this parabola, we've thrown it out. And we did that when this technique called for us, the technique required that we do that, because the technique said switch x and y, which means switch the domain and range. So this range that was -infinity to 6 became the domain, which cut this parabola now in half. But that's a good thing as far as functions go, because now this graph does pass a horizontal line test. And so this is a function. we had to restrict the domain to make it a function. So I can use my function notation f inverse and say 1/3 x minus 6 squared plus 7/3, but I need to either state this domain either in interval notation, or sometimes you'll simply see it as an inequality to indicate to people, don't use the entire parabola, only use the left half of this parabola. And yes, the parabola was a function, but now it's an inverse to this original function that was a square root function. So that's a lot to take in. Ask me questions as needed, and I will talk to you later. Bye.